In question 9, we need to prove that a process is a Markov process, a Markov chain. Then it is statistically determined by the second order probability mass of P xi equals xi, xj equals xj for any ij equals 1, 2. Okay, in order to prove that, we first write the process P of x1 equals x1, x2 equals x2, to xn equals xn. And then we write the conditional probability of Pxn equals xn, given that xn minus 1 equals to xn minus 1, given that the previous term equals to the previous term, till x1 equals x1. And using the law of total probability, that equals, we need to time it by P of x n minus 1 equals x n minus 1 all the way to x1 equals x1. And that we can say it equals to P of xn equals xn, given xn minus 1 equals xn minus 1, times P of xn minus 1 equals xn minus 1, given that xn minus 2 equals xn minus 2, and all the way to P of x2 equals x2, given x1 equals x2, 1, times P of x1 equals x1. And here we can already tell that this process is determined by the second order probability mass function. And then we can write P of xi equals xi equals to the sum of k equals negative infinity to infinity of P xi equals xi and xj equals xj. And the conditional probability of P of xi equals xi, given xi minus 1 equals xi minus 1, is equals to P of xi equals xi times Pxi minus 1 equals xi minus 1, divided by P of xi minus 1 equals xi minus 1. And we can tell that if x12 is a general sequence of a random variable, then it is statistically determined by its nth order probability mass. And here in this one, we have proved that if x12 and all the way to xn is a Markov process, then it's statistically determined by the second order of its probability mass.